Carter property, totaling 107 acres, is a property within the southern half of Section 17, Township 54 North, Range 33 West, near Chassell, Michigan. This land was previously owned by Alan Carter, who ran a simple berry picking business and some cider production. After his passing, the property was gifted to the Evangel Community Church, who are now in the process of building a community garden there. This tract is a mix of open fields stemming from retired agricultural land, northern hardwoods forest, and mixed forest.
The Evangel Community Church approached the College of Forest Resources and Environmental Science and expressed their interest in how they can better manage their land for forest resources and improve the recreational quality of the tract. Furthermore, they expressed interest in creating multiple revenue streams via tree and crop harvesting and wanted recommendations on how to sustainably maximize their resources. Our team, comprised of forestry and wildlife management majors, were assigned to this project. Together, we created a set of goals followed by a list of objectives with the landowners. The three overarching goals for this project were to provide the landowners with an accurate forest inventory description/analysis, assess the agricultural and recreational potential of the land, and identify uses for timber and recommend a silvicultural prescription.
To start, we conducted an intensive forest inventory and statistical analysis on the property. 4 stands, or stratum, were delineated in ArcGIS Pro, and a set of 57 random plot locations were generated for field sampling. At the plots, trees were measured on an overstory, understory, and herbaceous level separately. Diameters, heights, ages, crown positions, and other metrics were measured to gain a better understanding of the forest structure. Additionally, a high-resolution aerial photo was made from scratch using a matrix of photos taken by a DJI Phantom drone. Overall, 777 photos were taken with a resolution of 4 centimeters per pixel, georeferenced with an accuracy of a couple millimeters. This improved the quality of the maps that could be created for the property owners and provided a very clear look at the variant stand structures on the property.
The forest inventory data gathered at the plots was translated to Excel and separated by stand. Statistics were computed by species and by diameter class on a per acre basis for overstory and understory layers. Additionally, sawlog and pulpwood volumes were calculated for the overstory on a per acre basis so that stands could be assessed on a timber harvesting scale. Each member then chose an individual project that would encompass one of the overarching goals. To assess the invasion of non-native vegetation on the property, one team member mapped the spread of species like buckthorn and autumn olive. It was recommended that the property owners target these invasive species before pursuing any agricultural endeavors. To improve the beekeeping activities taking place on the property, another team member recommended manual planting of native wildflowers in the open fields near the apiaries or beehives installed by the landowners.
To evaluate the potential for agricultural activities, specifically Christmas tree plantations, fruit orchards, and tree nurseries, another team member mapped several locations that could be used for this purpose. General logistics, including cost and viable species that could be used, and planting techniques were prescribed. Lastly, to evaluate timber resources, the harvestability of red oak and red maple were assessed based on a volume projection model. A shelterwood harvest was then simulated with present net worth values provided in 5-year time increments. Overall, the information gathered was formatted into a professional management plan. The landowners intend on using our recommendations to make educated decisions for property management into the future.